Thanks for purchasing UV-Vis spectrophotometer. This video mainly introduces the instrument operation with PC mode. The computer configuration requirements of UV-Win6 are shown as above. The installation of UV-Win6 is very simple. What you need to do is to run setup.x in the installation disk to start the installation program. Follow to the prompt of installation program to finish setup. You can choose all users or only for me, according to your demand when it's prompted to choose application authority. The serial number of software is kept in installation pack. Please input the serial number when it is prompted. Setting the communication port between PC and instrument. After you choose a port, click on Test button to test if it exists and show test status. When it shows on, it indicates that the port exists. Otherwise, please test another one. Please notice that status of online meaning the port exists. But other program may use it. So you have to run UV-Win to confirm it. Selecting accessories that the instrument uses. The option includes 8-cell holder, 5-cell holder, fixed cell holder, fixed flow cell holder, and integrating sphere, as shown as above. You may select it according to instrument outfit. In Help tab you can get description of how to use UV-Win6 configuration program. After you finish configuration, click on OK to save settings and exit. When you are going to run UV-Win6, be sure that connection between UV-Vis spectrophotometer and PC is good and instrument is turned to PC mode. Here, you can click UV-Win6 shortcut to start it. If instrument works normally, it comes the instrument initialization window. If initialization fails, system will display an error message. Select Yes to enter into system, or No to exit. Please notice that when initialization fails, you had better not to enter into system to operate instrument, as initialization failures have various causes. It is possible that there are some problems on instrument components. If you do some work on defective components, you may make some needless damages. So be best to exit system after initialization fails. Then read Instrument Service Manual at first, or contact Serviceman. After initialization, it enters into the UV-Win6 main user window. UV-Win6 layout is shown as above. Menu bar. A majority of functions in the software are provided in menu bar. Menu bar include submenus of File, Edit, Measure, Figure, Mathematic Calculation, Administrate, Tools, Application, Window, and Help. You can use menu functions provided in menu bar to accomplish its corresponding setting for software. Toolbar. The role of toolbar is listing those commonly used functions together as tool buttons. In this way, users can achieve menu functions by single press of these tool buttons, so as to dispense with those trivial menu operations. Status bar. Status bar locates at the bottom of whole window, which is used for display of status message in software. For example, status of command execution, data file type, current username, file call schedule, etc. In the spectrum window and the time course measurement window, status bar also displays actual coordinate values of current cursor located. Tree type window. The tree type window is a structure of commonly applied in software design. Its characteristics are more visual, convenient, and framework clear. In UV Win 6, there are two tree type windows. One is used for display of each performance module files in Workspace, called Workspace window. Another one is used for display and control of instrument accessories, called Accessories window. Regarding detailed application of Accessories window, it'll be introduced later. Module window. As a matter of fact, the module window is a sub-window of main interface window. The fact to call it as module is that each window can accomplish different measurement functions. The module window consists of the Photometry window, the Spectrum window, the Quantitative window, the Kinetics measurement window, and the Spectral bandwidth scanning window. You can enable each module window by using mouse to hit window title bar, or by selecting corresponding module name in Workspace. In order to get accurate and reliable test results, the instrument shall be warm up for at least 60 minutes before performing any analysis. In photometric mode, click Parameters button on the toolbar. Set the wavelength to 440 nanometers, 546 nanometers and 675 nanometers. In repeat measurement, select Automatic function. Set the repeat time to 3. Select Calculate average value. Click OK button to close the window. Keep nothing in sample compartment. Click Auto 0 button to set the absorbance to 0. Put the neutral filters into the sample cell holder respectively. Click Start button to test the filter one by one. After the test, compare the test result with the expected value. The difference between the average of 3 measurements and the expected value is the absorbance accuracy. The difference between the maximum value and the minimum value of the 3 times measurements is the absorbance repeatability. In photometric mode, click Parameters button on the toolbar. Set the wavelength to 198 nanometers. In repeat measurement, select No. Click OK to close the window. Put the stray light blank into the sample cell holder. Click Auto Zero button to set the absorbance to 0. Replace the blank solution with sodium iodide. Press Start button to test the stray light. Record the test result to check if it's meet to the requirement. In Spectrum mode, click Parameters button. Set the Start button to 650 nanometers, end wavelength to 230 nanometers. Set the scanning speed to medium. Click OK button to close the window. Keep nothing in sample compartment. Click Baseline button to set the absorbance to 0. Put the holmium filter into the sample cell holder. And then click Start button to start scanning. Repeat the test for 3 times. Click Peak Picking button on the toolbar. The instrument will detect all peaks and valleys on the spectrum and show the results in the table. The difference between the average value of 3 times scanning and the expected value is the wavelength accuracy. The difference between the maximum and the minimum value is the wavelength repeatability. In Spectrum mode, click Parameters button on the toolbar. Set the photometric mode to S. Set the start wavelength to 660 nanometers, end wavelength to 650 nanometers. Set the scanning interval to 0.05 nanometers. Click OK button to close the window. Click Start button to start scanning. The peak width at half the height of the peak is half peak width. In Kinetics mode, click Parameters button on the toolbar. Set the photometric mode to ABS, wavelength to 500 nanometers. Set the display range between 0.001 and -0.001. Set the measure time to 120 seconds. Click OK button to close the window. Keep nothing in sample compartment. Click Auto Zero button to set the absorbance to 0. Click Start button to test the noise. After measurement, record the maximum and minimum value of absorbance. The difference between the maximum and minimum value is noise. In Kinetics mode, click Parameters button on the toolbars. Set the measuring time to 3600 seconds. Set the display range between 0.002 and -0.002. Click OK button to close the window. Keep nothing in sample compartment. Click Auto Zero button to set the absorbance to 0. And then click Start button to test the baseline. The difference between the start point and maximum deviation in the full range is baseline. Photometric measurement is readout of measuring data at the wavelength points you set. In UV-Win6, you can set multiple wavelength points for photometric measurement. Furthermore, you can do some simple calculation on measured data. To enable photometric measurement, please click on the Photometry tab in Workspace. Select Parameters on the toolbar to activate the Photometric Measurement Setting dialog box. In this dialog box, there are 5 tabs, and you can set up them according to your various needs. After parameters setting, put blank solution into the sample cell holder. And then click Auto Zero button to set the absorbance to 0. After Auto Zero correction, put the sample into the sample compartment and then click Start to test the sample. The measured result is displayed in result table as above. Spectrum scan is scanning on a certain wavelength range with a definite wavelength interval. In the scanning course, it gives readout of measurement data with each wavelength changes and display the measured data in a graph of 2 dimensions for further analysis and study. Spectrum scan is mainly used for qualitative analysis of samples. With its visual graphic display, spectrum scan is more clear for operators with samples properties. So it is one of the absolutely necessary functions for UV-Vis spectrophotometers. If you want to perform spectrum scan, first you should set scanning parameters. Please click on the Spectrum tab in Workspace. Select Parameters Settings button to activate the Spectrum Scan Setting dialog box. Set the parameters according to your requirements. And then click OK button to close the window. Put the blank solution into the sample compartment. Click Baseline button to correct the baseline. After baseline correction, put the sample into the sample cell holder. Click Start button to start scanning. System will draw dynamically scanning data and wavelength on the spectrum scan window in graphic mode. Click Full View button on the toolbar. System will automatically regulate the coordinate range of spectrum graph to bring all spectra displayed normally. Click Peak Picking button on the toolbar. System will automatically detect peaks and valleys on the spectra and show the results in a table. Click Read Spectrum button on the toolbar. System will draw a vertical line on a spectrum. You can use mouse to drag the line to read out spectrum data. Click Read Screen on the toolbar. System will change cursor as cross cursor. In the meantime, you can move cursor on spectral graph and system will show the corresponding coordinate values. Click Display Cursor button on the toolbar. System will draw a cross cursor in the center of spectral graph. You can move mouse to the center of cursor. Click mouse left key to drag the cursor moved. Click again to fix cursor at the appointed position. Stretch and shrink or zoom on coordinate axes separately. You can choose the Zoom Action button on the toolbar as you required. Curve Display offers view the various options for curve display. The optional display modes include line, point, cross point, dot, and triangle point. You can click on corresponding button on toolbar to change the display. Click the Measure Distance button on the toolbar. The system cursor will show as a ruler. At this time, you can click the mouse left key at any position on the graph. Then move the mouse to another position and click the mouse left key again. System will automatically shows the calculation result of the line distance, the vertical distance, and the horizontal distance of the 2 points. Click Zoom Window button on the toolbar. System will show the cursor as a magnifier. At this time, you can move mouse to any position on the graph and press the mouse left key. Hold it and drag the mouse to draw a rectangle of zoom area. Release the mouse to zoom in. If reverting is required, you can click Undo Zoom button on the toolbar. Quantitative is a determination method by comparison of measured values of standards and samples to calculate sample concentration. Quantitative has many measurement methods, such as single wavelength, double wavelength, three-wavelength, first-order derivation, second-order derivation, third-order derivation, and etc. To enable the quantitative window, you should click on the Quantitative tab in Workspace. Click Parameters button on the toolbar. In this dialog box, there are 6 tabs: Measurement, Calibration Curve, Instrument, Accessories, Quality Control and Simple Calculation. Please set the parameters according to your requirements. After parameter setting, put the blank solution into the sample cell holder. Click Auto 0 button to set the absorbance value to 0. and then put the standard solution into the sample compartment. Click Start button to test the absorbance of the first standard solution. The system will prompt you input the concentration of the standard solution. After input of concentration, click OK button. System will add a standard automatically. Whose concentration is what you input, and then start measurement of the standard solution. Test the rest 3 standard solutions in sequence with the same method as above. After testing, system will build a standard curve automatically. The detailed info is listed on the right of the screen. Move your mouse to the sample table. Put a sample solution into the sample compartment. And then click Start button on the toolbar. System will detect the absorbance of the sample and will calculate the concentration according to the standard curve automatically. If you want to print out measured results, you can click Preview button on the toolbar to preview the test report, and click Printer button to print them out. Naturally, you must to ensure that your PC has already installed a printer. If not, system will prompt an error message. Kinetics is a measurement of continuous reading at a certain time interval and graphic display of measured data. The method is mainly used for observation of sample change trend with time. To enable the Kinetics window, please click on the Kinetics tab in Workspace. Select Parameters button on the toolbar to set the Kinetics parameters according to your requirement. Click OK button to close the window. If there is a blank solution, put the blank solution into the sample compartment, and then click Auto 0 button to set the absorbance to 0. Put the sample solution into the sample compartment, and then click Start button to start test. System will detect and display the test result graphically. The above is the entire content of the operation in PC mode. Thanks for watching.